Consider a mass executing simple harmonic motion with an amplitude of x0. The mass moves with maximum velocity when it is at the equilibrium position. The velocity is zero when the displacement x equals negative x0 and x equals plus x0, where x0 is the amplitude of oscillation. Click the play button and observe the variation of displacement x with the time t for a body performing simple harmonic motion. The graph obtained is a sine curve. From the graph, displacement x can be represented by the equation x equals x0 times sine omega t. Observe the equation for displacement x in simple harmonic motion. The equation for displacement is x equals x0 times sine omega t. Click differentiate to differentiate the equation. D over dt of x equals x0 times omega times cos omega t as d over dt of x equals v. Velocity v equals x0 times omega times cos omega t. Click the play button and observe the graph of velocity v against time t being plotted. To deduce the equation for acceleration a in terms of time t, click differentiate to differentiate the equation. V equals x0 times omega times cos omega t with respect to time t. D over dt of v equals negative x0 times omega square times sine omega t. Acceleration a equals negative x0 times omega square times sine omega t. Click the play button to observe the graph of acceleration a against time t being plotted. From the graphs, we can observe that velocity leads displacement by pi over 2 radians. The acceleration and displacement are in antiphase, that is, phase difference of pi radians. Click on time t equals 0 in the graph and choose the corresponding values of displacement, velocity and acceleration. Click check to verify the answer. Repeat the process for the other values of t. T equals t over 4, t equals t over 2, t equals 3t over 4, and t equals t. Consider a mass executing simple harmonic motion with acceleration a and displacement x, represented by the equation a equals negative omega square x. Solution for the equation a equals negative omega square x is given by x equals x naught times sine omega t. This can be proved mathematically. Click on the steps one after the other in sequence. X equals x naught times sine omega t. d over dt of x equals v equals x naught times omega times cos omega t. d square over dt square of x equals a equals negative x naught times omega square times sine omega t. Since x equals x naught times sine omega t, a equals negative omega square x. Summary. For a simple harmonic motion, displacement x equals x naught times sine omega t. Velocity v equals x naught times omega times cos omega t. Acceleration a equals negative x naught times omega square times sine omega t. Velocity leads displacement by pi over 2 radians. Acceleration is in antiphase with displacement. For simple harmonic motion, x equals x naught sine omega t and v equals x naught times omega times cos omega t. Click square button and follow the steps to derive an expression for velocity v equals plus or minus omega times square root of x naught square minus x square. On squaring we get x square equals x naught square times sine square omega t and v square equals x naught square times omega square times cos square omega t, which equals x naught square times omega square times 1 minus sine square omega t, which equals x naught square times omega square minus x naught square times omega square times sine square omega t, which equals omega square times x naught square minus x naught square sine square omega t. Since x equals x naught sine omega t, v square equals omega square times x naught square minus x square. Therefore, v equals plus or minus omega times square root of x naught square minus x square. The variation of velocity v with displacement x is given by v equals plus or minus omega times square root of x naught square minus x square. The graph of velocity v against displacement x is an ellipse. From the table, we observe that for all values of displacement except for x equals plus or minus 8 centimeters, there are two values for the velocity, one positive and the other negative. The mass passes each point twice. When the mass is moving from right to left, the velocity is negative. The velocity is positive when the mass passes the same point from left to right. Summary: x equals x0 times sine omega t is the solution of the equation of simple harmonic motion A equals negative omega square x. The expression for velocity is v equals plus or minus omega times square root of x0 square minus x square, where omega is the angular frequency, x0 is the amplitude of simple harmonic motion, and x is the displacement. The velocity displacement graph is an ellipse.